My name is Kyle Macbeth, and my project is on steganography detection. Steganography, in a broad sense, is a method of communication in such a way that only the intended recipient is aware of the communication. Like many technical words, it comes from a Greek derivative, and it means covered writing. When it comes to computers, steganography means hiding the bits of a file inside another file. While in class we only covered hiding files inside pictures, there are also methods to hide files inside audio and video files. Programs can only be as good or evil as they are used. Steganography has innocent uses, like you can use it to send secret messages to your friends. It can also be used in education like we did in class. Steganography has criminal uses. It can be used to discreetly send away company records. Child porn distributors could use it to hide the nature of the things that they are sending out. After 9/11, there was media hype that terrorists were using steganography to coordinate attacks. This is an exaggeration, because steganography works best as a covert tool when it does not arouse suspicion. No matter how innocent the picture you send to a known terrorist organization is, the fact that you're sending it to a known terrorist organization means it's going to be under suspicion. A simple way to check for the possibility of steganography use is to check the programs. If there's a program for steganography, then there's a good chance it's being used. A dead giveaway is if they have the file name steg after the name of the file. Some programs change the file signature when they use steganography. One of the most significant ways to identify steganography is to compare the suspected picture to the original. When steganography is used to put a file into a picture, an algorithm slightly alters a few of the pixels in the picture in order to represent the bits of the file that is hidden. The changes in the pixels are very slight, and the pixels themselves are so small that it's virtually impossible to tell with the naked eye. There are ways to make the changes visible by comparing the steg image and the original image through a filter. This is what I will be doing in my demonstration. The program I'm using now is called Paint.net, and similar to the program we used in class, it's a good Photoshop alternative. I have two layers right here. The bottom one is the basic picture. The top one, which is now visible, is the stegged image. You can't see the difference because there is almost no difference. At one point in class, we talked about exclusive OR, which means that when two things are compared, any corresponding thing that is the same results in a 0. Anything that is different results in a 1. There is a layer filter in Paint.net that does something similar. It compares the two pictures, and whenever the bits that are on top of each other are the same, it will turn black, and whenever they are different, they will turn different colors. We can use this to identify and pick out the points that are changed through steganography. We have both layers visible, and change the blending mode to exclusive OR. As you can see, most of the image disappeared, as those were the parts that were the same as each other. The tiny little bits that are left are actually the coded part of the file that was placed inside the picture. I will now demonstrate how different sizes of pictures and different sizes of files hidden will change what happens when we use exclusive OR to find the adjusted pixels. The file hidden within this picture is the same as the one that was in the previous one. Now use exclusive OR. The changed bits are actually a lot harder to see because they're still really small, but the picture is so much larger. Now we'll see what happens when you have a larger file inside a large picture. The file that's in these two is much smaller than the one inside this one. You'll be able to see the difference in the size of the file by how much pixels are changed once we use exclusive OR. These are all pixels. All of these were changed slightly in order to accommodate such large file size that had inside the picture. So compare all of these points changed to these points changed. All in all, this shows that steganography can be detected if you have the original picture as well as the stegged file. It's one thing to find out that there is a file inside a picture. It's a whole nother can of worms taking the file out. Some steganography software includes passwords, so it's encrypting the file as well. This means that it has both anonymity and armor. Removing a file from a picture or another file would require the reverse of the algorithm that was used to put it inside the file in the first place. What makes computer sciences so exciting is the fact that there's always room for new innovations. New and creative ways will be made to hide the files, and in response, new ways will be made to find them, and it's a cycle that will go on and on. But that's just how progress works.